Okay, let's do axiom of choice first. Okay, let's repeat again what's the axiom of choice here. So first condition, first situation you think about is you take few set of disjointings and you can choose, choose one element from each set. Okay, so this is the usual axiom of choice. Okay, so what's the choice function here? We put it as a set C, set D, such that when you take C intercept at each bucket of things you can pick, you can only pick one thing. Okay, you just pick one at once. Okay, one at once. Okay, don't be greedy. Okay, second, wait. Starting got problem here. Is your Wi-Fi good or not? Your Wi-Fi good? Okay. Second is without non disjoint non-empty set, you also can pick from each set. Okay, although maybe you can pick repeated item is never mind. You still can pick. Okay, for the second one. This collection is not necessarily disjoint anymore, but you still can pick. Where still can pick. Okay, you still can pick. Okay, can follow. Can. Okay. Third one is if you take a set, okay, and then you jumbo, you mix it. Okay, look at different power set. Okay, you put 在一起，不同个分法。Okay, you still can pick. Okay, given any power set, any subset of X, you still can pick. You still can pick F A. Okay, inside that subset. Number 4 here, yesterday, I have a bit of confusion here. I tried to put X as a set of X. Okay, actually not necessarily. But here implies what? Implies that this H actually send X to a non-empty set. Empty set. Correct or not? Is it possible to do that? Is it possible to do that? For example, H 有没有？等个，明白？跟越重要。Okay, so Lydia, okay, Lydia sent to a bag. Bag is an element, right? But this bag is also a set of thing inside there. This bag actually is a set. Okay, so I mean what? Lydia get attached to a bag, but I have a choice function to take out as a sign. I actually can take the book out, or I can take the laptop line. Oh, sorry. I can take the this Yokohama. I know Yoko. Yoko. Okay, I can take the Yoko. Okay, but they are inside this bag. Okay, yeah, thank you. Okay, and then 5 is about relation. So if you have a relation, you also can pick a function out. So what's the difference between relation and function? Function, you need to make sure that for every the ordered pair you pick, for every A have a unique B. Okay, so for every A have to be a unique B. Or cannot you inside your function you cannot have A to B1 and A to B2 where B1 not equal to B2. Okay, you can only have a unique B for every. And then the last one actually is the most practical one that you need in our life. Okay, if your function is on truth, why is there we call it a left inverse? Because when you compose from the left, you get identity. Oh, this is the most practical one in our mathematical calculation. Okay, it turns out that the existence of the left inverse is the existence of axial force, huh? Right or left? Yeah. G go to B A. Oh, yeah, sorry. Hey, look at my proof. My proof got problem or not? See what happened in my proof. Is my proof got problem? Six. Hey, my proof also got problem. Oh, let's see what's wrong here. So, or it's just writing the different way. So F is to A to B, B to A. What's wrong? Let me see. F to B, B. What's wrong? Why change direction?
G of the G function, that's right.
Mm-hmm.
And then you add such a G compose F is the identity, and the F is to the right potential.
When G is B to A to B. Oh, correct. Wait, why here something wrong here in my code? Let me see. So it's just wrong direction, is it? If G is B to A to B. Oh, okay. I think it's just wrong direction. Okay. Yeah, so I mean, we just write the domain and codomain down. So B goes to A. Hey, no way. What's wrong? It's fine. I still can compose.
You're right.
Uh-huh. Oh, what did I say just now? Oh, okay. So I get the left, right, wrong. Huh? Oh, I thought I composed my function wrong. Okay. Sorry. So it's right. Yeah, right. Okay, right. Thank you. Yeah, the right. So you compose from the right. Okay. Oh, I thought I composed my function wrong. Okay. Okay. Thank you. Okay. So, let me show you 1 to 2, 2 to 1. Okay, and then later I give you time to try the other direction. So our strategy is 1 to 2, 2 to 1, and then 2 to 3, and then 3 to 4, 4 to 5, 5 to 6, and then 6 back to 2. Okay, we'll do 6 back. And then we will have a loop going around 6 elements here, 6 statements here. Okay. So 1 to 2, 2 to 1, actually one of the directions is easy, right? One direction is easy. Which direction? 1 to 2 or 2 to 1? 2 to 1, right? 2 to 1. Yeah, correct. Because 1 has extra condition, but they are still non-empty set. Okay, so the problem is how to go from 1 to 2. So meaning if you know that you know how to pick elements from disjoint set, but now the set is not disjoint anymore, still can pick or not. Right? Can you still do the picking? Okay. So what is the strategy? You have non-disjoint set, but the first item asks you to make a disjoint set. Okay, so you need to come out a disjoint set from non-disjoint set. Okay, so this is the technical part you need to do. What do you think? How to make a disjoint set from non-disjoint set? Oh, say that one is obvious. Okay, now we'll do 1, 2, 3. How do we do this? Well, so here is the trick. So let's tell you the trick. So we'll define for every B in B. So we're going to build this joint set here. So we call it B prime. Okay. For every B, we put a B prime here. How do we make them different? We take a tuple where B, where it contains B in the first coordinate. Second one is just S, such that S is in. Again, note that where does this set live in? This set live in B. What is that? This set live in B. Close union of all the set. Okay. Understand what this means? Okay, so we have a set of set. You pick it up and then pair with everything inside the set. 你很难想象嘛？其实不难想象。最近家里不太家里有点不幸，多不幸哎。这里全部听华语对吧？Can understand everyone here? You can understand. Can okay. If cannot, you ask one. So because 人到了一个岁数，不是大了啊，家里的长辈也会跟着长大，是不是？也会变老，对不对？就差不多要喊进去啊，喊进去要讲话呢？烧掉。OK， 我没有烧掉，我不会被烧掉，但是就是有财产要分很大的问题，会吵架的哦，对，要官司。一个屋子哦，全部人住在里面哦，怎样分？怎样分啊？什么？卖了半钱 ，OK， 你这个真的是太那个，太直男，太直男了，是不是？卖了变卖不卖了。但是还有一个东西嘛，就是来共同的产业嘛，说这个家每个人都有一份名 ，OK， 每个家都有一份名，这个家就不一样了，你知道吗？不是一个人了，不是同一个家了，为什么？因为你要过名，你要卖，你要去 loan， 你全部每个人都要签名，你就把家分掉了，就不同了。虽然是同一个家，OK， 有不同名字在上面啊。OK 吗 ？It's a different set already。每个人都要经过 approval 才可以动这间家。OK 吗 ？OK， so what we do is we don't just look at B, we look at B with some element labeled by some element inside. Okay, so this is a new set. Okay, so first thing we want to say is this B this B prime this B prime obviously again is non-empty. Why non-empty? Because we already start with a non-empty set. By the way, this is the condition too. Please don't forget. And then not that. What we want to produce is if B1 not equals to B2, then B1 prime intercept B2 prime should be and see why. See why? You already have one coordinate is different, right? Okay, they should be not the same. Okay, the intersection should be empty. Okay, even if S1 equals to S2, still not the same. Okay, so even if the labeling is the same, even if the labeling is the same, even if this is the same, B1, X1 shouldn't be B2, X2. Okay. Okay, maybe you have the same guy but you have different property. All right. So now we will take the new set code D here, okay, which is the collection of B prime now. Now this is a collection of disjoint, non-empty, or it might not say empty, non-empty subset of B cross union B. Okay. Okay, but note that you see, we somehow enlarge the set already. Okay, because the original set has intersection, but now we enlarge it. And then we do axiom of choice here. Then you need to put the choice back to the original B. So this is the thing we're going to do next. And so now we enlarge the set now. Okay, so by enlarging the set by A or C, axiom of choice number one, and number one choice that exists. A set choice, okay, we can make a choice, consists of what? Consists of exactly one element, okay, one element from all the BI, or which, in other words, from all the element in C. Okay. Now our claim is this C is the desired choice function that we want. Okay, so what do we need to show here? We need to show that C can pick from the original B such that CB is an element in B. Okay. All right, so it's a function, right? So another way to talk about function is use set definition, right? So first of all, C is a subset of B cross union of all the set. Is this right? Let me think. So if we use this line here, we get, so we union all these A together. Does this look wrong? This seems wrong. Is it correct or not? This is a subset. Is this wrong? What do you think? Is this correct or not? Okay. This is correct. Mm-hmm. This is correct. This is correct or not? Let's think about it. So what we want to argue is this C is a choice from B to union of B. In other words, we want to show that C is a subset of B cross this. Okay. So why is it true? So by the first axiom of choice, right, you can pick one element from the set containing B prime. Okay, the set containing B prime. And then hey, try to think about it. Huh? Why? I mean, wait, what's B prime? So the elements inside B prime look like what? B with something. Okay, B with something. Okay. Uh-huh. Okay, so I mean, wait, before that. So if we do C of B prime, okay, we're actually picking B on something. B with label with something. Okay. And then moreover, we can do it for all B prime. Okay. Okay, I don't want to write this confusing notation first. Okay. For all B prime, we can pick one BX. Okay. And then by AOC, you can only pick one. Okay. So it's unique. Okay. Does it make sense? So to satisfy a function definition, what do you need? You need to define an image for every element in the domain. Okay, and then that image has to be unique. Okay. Okay. And then are we done yet? Are we done actually? Are we done? But what we want is we want the C to go from B. So instead, so we can define what? Okay. So wait, so what's our goal here? We want to define a function from B actually. But just now it's from B, the set containing B prime. Okay, how to turn it into a function from B? Okay, how to turn it into a function from B? Okay, so let me write down. We define choice function. Let's call it D. D from B to union of B here. Okay, so now you will see how to get this B here, D here. You know how to go from B prime, set containing B prime. Then do you know how to go from B or not? What is the relation between B and B prime? Let me put something in the middle here. Where's the enlarged set? We put the enlarged set in there. Maybe we can put the enlarged set here. So B union, not union, cross with. Right. So if I give you a B, okay, just go and look for the B prime. And then you can use C to read out the. C doesn't read out the. Okay, so where does the C live? Where's the codomain of C? Huh? We go. Mm-hmm. Wait, wait. Don't know what's that. What's it? Lines, don't. Okay, so where is it? Okay, so you can put your B inside this B cross UB, right? Okay, send to the B prime that consists of B comma something. Okay, and then you can use your C to read out, pick a choice, right? B with an X. Okay, where does this B comma X live? Right? Let me see. Did I write things wrong or not? Where is this guy living? I think I write something wrong here. This is not the space where B prime live. Where B prime live? Do I just call it a set of B prime? Oh, yeah. We call it C. Wait, sorry, we call the name already. Here got the name C. So this is C. Okay, we can embed our B inside our C first. Okay, and then we use the choice function C. And then what's the element in B we want to pick here? What's the element of B we want to pick here? Is the S. Okay, it's the S. Okay, so here maybe we say projection. Okay, projection on the second element. Okay, first one is inclusion. Can we say inclusion? Yeah, does it make sense? Does it make sense or not? Okay, so I give you a B. So what you do is go and find the B prime that you build by using B. Okay, and then you use a choice function because these are non-empty already. Sorry, destroy non-empty. So you use your choice function and then pick up the BX. And then how do you pick out the single element? You project to the second coordinate. Make sense? Okay. Okay. Can? Okay. Okay. Any question? No question or no? Yes. Ah. Uh-huh. Uh-huh. Okay. 好像是，但忽然间我脑卡住。Okay, never mind. 也可以。Okay. Yeah. Yeah, so just now suggesting is because C already give you this BX. I think this BX is the solution already. But anyway, I write out in full what happens here. Okay, I just write out in full what happens. Okay. No question? 有问题吗? So the existence here is this existence of this C. And this existence of this C is given by axial of choice number 1. Okay, and then why this X is the singleton then because of the choice number 1. Okay. No question? Any question? Okay, if no question, I want you give you 5 minutes. So we go. How many directions here? About 1, 2, 3, 4, 5. 5 direction. 1, 2, 3, 4, 5. Okay, 刚刚好. So each row start with different implication. So first row start with 2 to 3, and then second row 3 to 4, and then third row 4 to 5, and then fourth row 5 to 6, and then fifth row 6 to 2. Okay, you guys try. Okay, 1, 2, 3, 4, 5. Okay, 试下。不同的 implication, what do you need to do? And then we will briefly discuss. Okay, I give you 5 minutes. 如果你讨论好你自己的 implication, 你可以传其他的。Okay. 来 try 一下。蛮好玩的啊。Well, the first time when I saw this Excel choice, I also didn't quite appreciate it. 看起来很难。Actually, 蛮好玩的其实。When I was a second year, I feel that this 不能理解、无法理解的东西。turns out that 蛮好玩的。Okay, try 一下。 2到3啊。啊，像是吧？可是有一个情况是你要决定嘛？啊，MD 线你要解决是 MD 线要解决吧？对，MD 全包东西你要做什么？没有，因为你要 define 是一个方阵从哪出来，所以你也要跟我讲 MD 去哪里。就是我那边的。对，你 define 这个方式，然后 SC 去哪里？就是不可以存在那种，所以我们要讲这 MD 一定是去把 MD。那里有东西在，你那里有对那个东西。哎，你们没有学过 partial ordering？我才发达了才知道，你们不是有学 relation 吗？没有啊，equivalence relation 接下来就是 partial ordering。你要有 partial order 才可以到 linear order。不是 simply on，simply on。不可能没有吧？对哦，第一个他的老师说他已经播出来完全哦，跟我。只是好像一个方面的然后人的方式还有都是哎，因为前面就可以讲远了。对，明天会哦，然后好，我再说，Okay, let's try. How we go from 2 to 3. First row, got any idea? Any idea? First row. Adrian, 你不是有 idea 吗？ So you have to start from non-empty set. Suppose X is non-empty. Okay. What we want to define is what? We want to define an F going from the power set of X, go to X. This one. Oh, sorry. Not equal empty. Okay, such that FA is in A and FA is in EX slash alpha. Sorry. Pi. Okay. And OK， 现在是这样啊，现在我们玩一个东西叫逻辑解题啊，不知道举办不知道他在讲什么，但是我们用逻辑解吧。OK， 所以我们去找一下它的共同性在哪里。OK，where their similarity。OK， so this is the function I want to define such that FA in A. OK，FA in A 什么意思啊 ？But at the top there, what do you have 啊？CB in union of V. So can you think union of V as some A and then FA as some CB? Yes, how? 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 Huh? There's a function. No. What I want to say is before you define that C, right, for sure you need to find that script V first. So what the script V you want to apply here? Who is the script V? Okay. If the script V is power set, then this C will give you the union of all the power set. But 你想一想啊 you have an X. You take the power set of X. You 把它的 power set union 起来，拿到什么 ？X 啊？想看 ？Think about it. So if B equals to the power set, okay, all the subsets are built by elements in X mark, correct enough. And then you union all the subset together. What is it? You still get back your original set. 想不到 I try. Like this. Okay, this is X. Okay, and then what's the power set of X? I think we discussed this before, right? Empty, set containing 1, set containing 2, set containing 1, 2, 3. And then you take union of all these. The elements are repeated. But if you combine all of them, what are they? So if you take union of empty set with 1, with 2, 1, set containing 2, set containing 1, 2, what is it? It is just set containing 1, 2. 对吗 ？OK， 合理吗 ？Union 呢 ，as long as in one of them， 一在这个，二在这个，二在这个，这个不用管它，这个 empty。OK，empty is always a subset of every set. Okay, so now you can define, but this C only define on non-empty set only. So meaning what? You can only define on Y such that Y is not empty. So if Y is inside PX, but it is not an empty set. Okay, here we. So let's move in a bit. But as I said just now, empty set is still an element inside power set. So you still need to tell me what happened if Y equals to empty. What happened? Go where? 去哪里？啊？去哪里？掐自己？你就送他去 anywhere. Send it to somewhere. What do you mean by somewhere? Where? S not 不要绕来绕去 as S not is in X, since X is non-empty, 一定有一个东西在那边，放弃它就好。是哪一个 ？Don't care。如果你找不到它，它就 empty 了，就你肯定知道有一个。Okay. Does it make sense? Yeah. 有什么问题？问题来啊！你要送去哪里？送去 empty 啊？You want to 送 to empty? Empty is an element here or not? Not necessarily， 不是 no 啊，是 not necessarily， 有可能在里面，你知道吗？你要弄什么东西有 content？ I think we have discussed this before, right? We define one to be a set containing empty set. Empty set is in there. It could be an element. But depends what this S not is inside. Depends. Don't know what it is. Okay. This one is an example. Okay. Okay, question? Okay. Okay. So next. How about 3 to 4? About 3 to 4. Okay, let's do 3 to 4. Okay, so let's say you know you can define a function from a power set. How do you solve a problem on this picking an element from image of a function? Line second row, got any idea? Okay, wow, control power set. Yeah, cool. Right, before that, let's set up what we have first. So given a function h from A. Hey, do you think that this assumption a bit tricky or a bit fishy? 通常 function 不是会跟你讲箭头去哪里的哎，哎都没有哦，一般吧，故意的。Okay, 故意 imprecise, purposely imprecise here because it just says that the image of this HS is not a empty set. So from here suggests that it is a set which is not empty. So there's something inside there. Okay, there's something inside there. So now we're going to pick it up. So in this case here, if you want to use Tx, right, you must start with X. So what's the obvious X you can pick here? Do you need to take union? You need to take union. Can I take union? Okay, union. Have you write down the full something? I follow you also can huh? I follow you So step X is equals to the union of all X, all HX like this. This is what you think, right? Okay, and then okay, so this is the non-empty cell. Okay, so let's take a look at the power set. Then HX will be in PX. Let me think. HS is a subset. HS is a subset, right? Subset of X. Wait. So wait. HS is a subset of yes. Fair enough. Because union of HS already combine all the elements inside HS already. Oh, yeah. It's a subset. Okay, correct. I think, yeah. Okay. And then? So let's define F from A to somewhere else. Okay, so such that, how should I draw this better? How should I draw this better? Define A with a domain of A such that how to draw this better? So to some where should you go? Yeah, actually you should go to hx, right? And then by taking A to some fx. And so you need to define what is this. And then this guy here should live inside. Okay, so what's the definition here? Choice function apply on hs. So here, let's give a different name here. So which name we should change? Let's change this new function here. We hope that this is the function that we want in statement 4. So you use the previous h, right? H f applies to what? Hx. Okay, but we start with A. Huh? HA. Okay. So can we do that or not? HA. Yeah, I think we can do it. So we got an element in A. Okay. That if this element in A, okay, so I think here let's change all of them. Okay. So we take an element in X in A, okay, and then we try to look for something in HS. And so what do? We take X, okay, and then we look at hx here. Okay, but hs is an element in the power set. Then we can use a condition that there's a f that can pick given hs, I pick an element in hs. Right. F of hs is in hs. Okay. This A here is hs. Okay. 有没有？有问题吗？问题。Okay. So this, you see, I look at this guy here is in hs. It's exactly the same setup. Okay. Okay. Or actually, I should draw a different arrow. This is by tree. Okay. Okay. So the key here is to how to like apply statement tree. So the key here is to find the non-empty set first. Okay. I don't know. And then the function will drop out automatically. Okay. The key here is to get the necessary, the sufficient condition. Okay. Yeah. Yeah. Let's continue 2 more, and then we can take a break. Okay. Now let's do 4 to 5. Yeah, let's do 4 to 5. Okay, let's try 4 to 5. So let's say you got a function that you can pick from an image set. Then now you have a relation. And then you want to pick up the function. Okay, let's try this 4 to 5. So let's suppose what we have first. So suppose this row is a relation. Okay, what is relation? It's just a set of ordered pairs. Okay, ordered pairs between A. Now we're going to define the new f. So let's call the new f bar from A to B. Okay, so if you want to use statement 4, right, you need the H first. H or not? Like third row, any idea? Do you have H? Do you have sub H? So, so do you have H? So define H to be what? A to outside of B. Okay, let's see why it works. Huh? Okay, see why it works. So how to define this? Outside of B. Okay, which subset? Okay, I use X here. Okay, so all the Y such that XY is in row. Okay. Why we want to do this? So naturally, what you have here, you have a relation, right? You have all the x, xy1, xy2, xy3, xy4, xy5, xy6. Okay. So what you do here is you take the x, I guess send it to 跟它有染的人，跟这个 x 有染的人，有 relation 吗？对不对？有染，OK， 所有有染的人放在一起，OK，Does that make sense？啊，很多小三啊，小四、小五都有的。Okay, yeah, depends. Then you can see that HS is actually a set. I guess 就是 is a non-empty set in particular. And it's a non-empty set because 可以乱乱选没有东西嘛，因为 because depend on this relation. And relation must have the order. Okay, you send to the guy that have relation with X. Okay, then how do you apply number 4? Number 4 says what? There exists, so by 4, there exists a F, okay, that have domain A such that Fx is in Hs. Okay. And then note that this Hs is an element in power set of B. Or in other words, is a subset of B. 有人看过这样子用 element 吗？很夸张的感觉。有人看过吗？这个在这个里面，这个在这个里面，这个不是俄罗斯号啊。Okay. Okay. Right. So in this case, how to define F bar? I think quite straightforward already. How to define H bar here? I think quite straightforward already. How to define H bar here? Define H bar. You send X to Fx. Okay, you send F to Fx. Okay. Such that you can check it. x and fx should live inside rho. Okay, the set of x and fx should live inside x. Inside. Correct or not? Correct or not? Because this is how you pick your x and y from. Okay, this is how you pick your y from. This is how you pick your fx. The xy already coming from rho. You just pick a particular one. How to pick a particular one? This is how the statement for pick for you. Fx in hs. From here, pick one. Okay. This one in. So pick one y. Okay, so this is the particular y you pick. And for sure, this pair is coming from rho already. Because this is where you look for them. OK， 没问题吧？脑筋要爆炸啊！再多两个，点自虐哈。来 ，OK， 再来一个 ，OK， 一个。另外一个就 homework，OK， 再一个 5 to 6。Actually, this one also very short. This is very short. 这个很短的，来，最后一个很短的，这个很短。哇，这个很重要哎，这个 I think this is pretty important for your assignment. But you don't need to write this long in your assignment. You just say by axiom of choice is enough. Okay, don't write this long in your assignment. You say by axiom of choice is enough. Okay, so how to build this right inverse? Okay, how to build this right inverse here? So you need to define right inverse. So let's write down what you have first. Very important in pure maths, you need to know what you have and then what you want to achieve. Very important. Okay. So suppose G is on 2. Okay, so we're gonna define this left inverse. Let's call it F bar also this new F to differentiate from the assumption F. Okay. So to use statement 5, right, you need a relation. The relation or not here? The relation. What kind of relation you want to look for? How to build relation? How to build this relation here? So you need to start with a relation so that you can use statement 5. Any relation you can build between A and B. There's an arrow for you, right? 有箭头就是有 relation. Okay, go look for arrow. So what kind of relation you can build here? So well, let's write down the double first because obviously this has to stay inside A equals B. But what's the relation between them? What's the relation? A and B. What relation I can put between them? 箭头 look for the 箭头. Yes, okay. As long as you can send B to A by G, we put them together as a pair. Okay. See if this works or not. So if we have this by 5, what can we do with this set? Let's check. I just simply guess one. So by 5, what can you do? There exists a function, okay, from A to B, such that F is inside this row here. So the claim is, what's the claim here? The claim here is just define this F bar to be X going to Fx. Let's check if this works or not. If this works or not. Let's check. Does this work? So here is F bar, sorry. Okay. So you got X, you send to Fx, And then you want to do G on fx. So let's check the composite. So A goes to B, goes to A. Then you do F bar, meaning you send X to Fx. And then you do G. G on Fx should go to where? To go where? Where is the Fx coming from? Fx come from where? Come from this row, right? Come from this B, right? What does this B satisfy? GB goes to N. So GFX equal to okay. Okay. Yeah. Because this morally speaking, this FX is just a B, one of the B that give you A under G mapping. Okay. We just pick one of them out. Okay. So yeah, we just pick one of them out. So the act of picking is very important. It's an axiom of choice. Okay. Any question? Huh? Okay, if no, let's take a break until 4:17. 什么？
第六在讲，不是选那一个的时候需要 action of choice 啊？对，你肯定选一个吧，你还可以选两个，你的方程都不会送去两个地方，对啊，没事啊。如果它不 on to 的话，你就找不到啊。我不是，呀，是，I mean，对对对对对，没有没有，I mean，对对对对对，I mean 不 on to 的方程，你只要把它没有到达，I mean，OK，白话文就是你拿它的 range，它就 on to 的 range，对啊，就这样。嗯，对对对，every function is on to its range。嗯，哪一个？什么情况？你说？
如果你要证明差不多的，
你要证明它是靠
这
的
是一般的。
啊哈，
因为那种那个后头那个要证明很久。
没有，你要证什么？现在什么 statement 呢？Something is countable, uncountable。Comfortably infinite 的 subset 是 n。Infinite 有两种 ，countable 跟 uncountable。然后，然后你要讲什么？
反正也是有圈子。在这里。
这样说现在还没有。
到后面一点点。
I come late just now, but actually I have to show you this meme again. This one.
The joke is I'm trying out to go back.
那边的情况出来，
如果我
那个 space 这样学 basis 是需要一些中文的东西了。
这样的话，你会好你都去吗？
我跟知道那个
你两个都 injective 的话，两个 injective 都不代表你要怎么？
是吗？然后放学，对，是什么？
他自己会学，那这个
所以这里全部 F 的句都有，对不对？
有
X 的那个。
就 F 等于
去 share 这个 space。
先开的地方肯定是外区同学。
嗯，
这样的话，你旁边然后我的部分同这一个
你是不是去？
就这样把这个给摆在地方。
他的白天可以肯定不对。
它可能合起来才把它地方不才不会啊。
我只需要一点地方。
我讲分开，它不会啊，它合起来会分开不会。没有，它可以合，不是你现在是说合起来会分开也会的。嗯哼，嗯嗯嗯
对，白天有 F 的对吧？
嗯哼，
也是拜托 F 的。
然后真的你要做模拟来吧。
这个我要这
如果这样合起来，就代表它是哦，对，我题目讲过，
你题目上我知道。
哦，你想用这一个位置，那可能是 F，那可能这两句话会有。哦，有个 table，哦，啊，
我这个不是谁出来啊？我都在
可以，但是我出这题的 point 是要你用那个 definition，但是如果你用那种 proposition 应该是 OK 的。
哦，
但问题是这边应该有在啊，举哦，
你做一个举出来。
哦，OK，毕竟我哦，
而且那个 TVV 可以是 S 嘛？
喂，我以前你不是问我讲清楚，
你这个定义啊 F
，F 跟
就 left right，
跟
所以你 left right 就一直用这个办法啦，就 F 给我乱转一下，然后就转一边就这个，转另外一边就这个，这不可以就转来转去吧，你把你的 F 放在外面就好了，因为我是左右啊。
我说
逻辑是可以的，把我想出这题的原因是让你去玩那个，去玩里面。
如果像他这么写会不会错呢？
会吧？
那很短诶，你直接
学到了。
两条哦。
对啊。那时候没有教这个，那时候没有教。
没有讲对，但是那个一定有讲。
那定义吧。
我记得我们 A1 的 notes 里面都有写。
一模完全如果
是你的。
但是但是这个题的东西也要大一点啊，也有这一题，因为第一个我们知道当时你有写这个我们要打进去嘛，
所以这个不是放到
solution。
对啊，像
啊，对，那你讲
UV，
那可以把 A 的东西直接复制过来
啊，
不要复制给他，因为我的三个题啊
这样就写 UV post after the data，就是
will be in the assignment 啊。
但 assignment 之后就可以放上去了。
对啊，以后会。
那你
你每年都要出同样的题啊，很坏。
可是只要有 A1 的笔记就可以找到。
对啊。
OK，
而且我们弄其他的时候，我们都已经避免了这个事情。
对，
不要写答案给他们，对不对
Leave it as an 然后放 solution。
？Leave it in the assignment。
是哦。因为你是说难题，
对，我感觉我们 A1 里面是不是放过3个？
没有诶，比较少，比较少。
因为我觉得你这个键值在反，我感觉反过来就吃你。
可以。Okay, so how about your assignment? Can finish on time or not? Cannot. Okay. How about next Tuesday? Tuesday midnight. Okay, Tuesday midnight. Because Tuesday afternoon still got office hour if you want to. Okay, but I'll release assignment too. Okay, I'll release assignment. So look at it first. Okay, if you don't do, look at it first. Okay, and then another thing, if you look at assignment first, you know what will be coming out. Okay, because whatever I talk here will be used inside your assignment. Okay, so if you have any question on your assignment, then during the lecture you already can start asking. Okay, so I think we have left active choice now. Oh, another comment I want to make about partial ordering. You guys didn't do in your first year. Did you guys do in first year now? Partial ordering got? Discriminant got, huh? Okay. I mean, one example of partial ordering is subset inclusion. Okay, so subset. Oh, I really cannot. Subset inclusion. Okay, subset inclusion. So meaning what? Subset inclusion is anti-symmetric. Is it anti-symmetry or not? This is the property you keep using, right, to prove two set is the same. Okay. Since if A is a subset of B, B is a subset of A, then A equals to B. Okay, so this is the anti-symmetry. Okay. Yeah. So whenever we talk about partial ordering, the first thing you think is subset inclusion. Then we can apply it. All right. So let's go to cardinality. Cardinality of set. And let's go to cardinality of set. All right. So first definition, two sets S and T are equivalent or equinumerous. Okay, so the number is the same, numerous as many if there exists a bijection. Okay, this is a bijection. F from S to T. So we write X is tilde to T. S tilde T. Okay. Correct or not? How do you count? The act of counting is bijection. 1, 2, 3, 4, 5. You are doing bijection to the number 1, 2, 3, 4, 5. That is a bijection. So easy proposition, we will prove it. So the equivalence of set is an equivalence relation. There is an equivalence relation. So meaning what? What does this mean? What things get partitioned? The collection of set get partitioned. Partition into what? Set with 1 element, set with 2 elements, set with 3 elements, 4 elements, 5 elements, okay, and so on. Okay, so let's define some terminology. So in this class, our n will start with 1. In this class, the n start with 1 natural number. We say that a set is finite if either it is empty or it is equivalent
to the set 1, 2, comma up to n equals some n. Okay, otherwise it is infinite. Later we'll see two kind of infinite. So first we define what is finite first. Finite is either nothing, you don't see nothing, or some is bijection to a set containing n numbers. 1, 2, 3, 4, 5, 6, 7, 8. Okay, otherwise, if this not both these cases, it will be infinite. If you cannot make bijection, okay. So now inside your mind, don't think about counting anymore. Think about bijection. And make a bijection again between n numbers. Okay, let's give some example. Two sets are equivalent. So for example, 2n and n. Okay. So how do you count? Obviously, this is an infinite set, right? Both sides. So how do you form bijection? So what's that map? What's the bijection that can you form? Sorry? N equals 2n. So where your n come from? Which direction you are going? Huh? What? Where your n take from? From where? Okay, so it's fine. Sure. So you start from n here and then you make a map to 2n by sending it to multiple of 2. Wait, what am I saying? Yeah, multiple of 2. Okay. Or you can do n from 2n, send it to n over 2. Yeah. So can you see that actually these two are inverse of each other? Okay, n to 2n and then 2n back to n over 2, so you get to n. And then n to n over 2, and then go to 2 times n over 2, which is n. Okay, so identity, okay, on both directions. Next important thing you need to know is actually an open interval is as many as the real number. This is quite counterintuitive. This is quite counterintuitive because you think that an open interval is a finite length, 长度嘛 b 减 a, right? But real numbers, infinite length. Although the length is different, but same amount of element inside it, up to a bijection. Yeah. 来，什么？很激动，好像你很激动，要不要讲什么？So how to build this bijection here? I let you think about 1 minute. See, yes. Any idea? Any idea? Let you think about it first 1 minute. So meaning we look for bijection. Can you build a bijection or not? Sorry? Yes. AB have to be in numbers. So let's put it in. Or A. Obviously we don't want A equals to B. A equals to B become not inversible again. You don't want to include M. Okay, so the point here is to find the bijection. Any idea? This question could be tricky. If you have a direct proof, you also can calculate. So idea here. For discussion here. Want to share? Huh? Want to share? Share. So, okay, so well, okay. So your idea is okay. So let's draw out your idea first. So let's build line like that. So let's say this is 2AB. Okay. So what you want to do is like you send A to negative infinity, send B to infinity, and then all these will follow spread out across the path. Okay, I think the idea is correct. Can you write down the function? How could you write down the function? Well, there's one way to send A to infinity, right? That's the thing that you don't like the most. I mean, we don't like in our calculus class. 1 over x minus a. Okay. Or negative 1 over 1 minus a. But can this map B to infinity at the same time? No. No. So what can we do with it? Times 2. Okay. Actually, you can try and think about it. You try and think about it. Okay. Use that logic. But what we're gonna do is step by step. Okay, let's do it step by step. Okay, instead of directly go to negative infinity to infinity, so what we do is we're gonna split it up. I think there's more than one way, but I will present you one way. So I will send it to 0, 1 first. Actually, the most standard statement is on 0, 1. Open interval of 0, 1 is equivalent to R. Okay. And then how is it equivalent to R? I will send one of the endpoint to infinity. So I don't have the 2 infinity endpoint problem like just now. I just want send one to infinity. And then from here, I can show that this is as many as R. Okay, so I'm going to use 1, 2, 3, 3 bijection. Okay, to show it. Okay, 3 bijection. All right. So AB, how to go to 0, 1 here? Any idea? This is like scaling. Scaling, this one. This one is a scaling. So if you have a interval from A to B, you want to scale it to do a translation and then scale it 0, 1. Okay. Do a translation and then scale it. So what do you do here? Actually, you send x to x minus a over b minus a. You should show that this is the bijection. It's just a scaling, right? And then plus a scalar multiple. Should be easily see this is a bijection. So write down the inverse. Try and write down the inverse. How about the next step? Do you still have bijection here or not? What can you do here? You keep one endpoint and then send the other one to infinity. What can you do is x over 1 minus x. This is not defined as 1, but doesn't matter because in our space there's no 1 here. Right, you check that this map is bijection. Okay, you can find the inverse. Or if you don't want to find the inverse, what's the way to show a function is a bijection? Your assignment. Show that it is injective and surjective. But now be careful. This is not injective or surjective on R to R. It's just on these two restricted sets. Okay, so please be careful. Okay, don't show on different sets. Okay, how about the last one? How to get negative infinity? Maybe you can try 1 over x minus x. Okay. Yeah.
It's not the first time.
Yes. So what should I do here?
I think it's
Quite confusing. Yeah. Sing. Okay, I think it's better to do that. So let's do like this. Okay, I think you are right. So let's do y go to y minus y over 1, and then go z to 1 over z minus. Okay, then you can do composition. Compose them together. You can compose them together. Okay. So if you compose them together, my calculation is not wrong. It looks like this. This is the bijection you want. Okay. Try and compose them. And compose them. I think this one give to from 4, from 5 also can do it. Should be able to do this. Okay. Okay. Continue. Next. Actually, there are as many natural number as integer. Okay, as many natural number as integer. What's the bijection you can do here? So let's define a bijection from n to z. So what's the bijection you can do? Okay, I mean to think about this question, right? In your mind, maybe you bring out your real number line. Okay, and then natural number is just 1, 2, 3, 4, 5, and so on. Okay, but in Z, you have more than that, right? You have 0, and then you have -1. Can we make our life easier? Can we make our life easier? Okay, let's do from n union 0 first. Let's do this. Let's make our life easier a bit. Yeah, sometimes people write this n as n subscript 0. Anyhow, so if I add a 0, does it make your life easier or not? Okay, so what's the bijection you can do? Bijection. So from 0 up to all the natural numbers, how to make bijection? Well, I mean, you need to start from some obvious map, right? Can I do this or not? Max is about trying. Max is about trying. Can you do this? If I do this, what happened? I cannot reach. It's not subjective. Any way to make it subjective or not? Right. What do you mean? Okay, I mean, suggest how do I change my arrow here? 1 to -1 and then 2 to 1 and then 3 to -2. Sorry. Oh, yes, -2. And then 4 to 2, 1. Okay, so now you suggest a rule, right? So what's the rule here? You send n to -n if, correct or not? 1 to -1, 3 to -2. So how to map this map? Negative n plus 1 over 2. If n is odd, okay? And then 0 if n is 0. And then n over 2 if n is even. Yeah. Okay, you can write down other maps also, not just this one. It depends on how you put your map. Okay. Well, I mean, yeah.
The way you choose this arrow, you can write down. Maybe you might choose some kind of arrow that the formula cannot be written. Depends. Okay. But arrow is the first idea you think about it, and then you come out with it. In this case, so I still want to ask a follow-up question here. So let's follow up. Does n as many as n union 0? Is natural number as many as the natural number? How? What's the projection here? So we send x to x minus 1. Okay. Okay, good, very good. Okay, I think you guys are ready to take the test already. Okay. Yeah. I think I don't do the last one. I mean, for this one, 0, 1 to r, because just now we already give you one possible way, right? The other possible way I want to show you is actually you see this in calculus. Actually, you see this in calculus. Okay. So if you remember the tangent function, where it goes to infinity, where it goes to negative infinity. There's some interval like that. And there's some finite interval. Okay, so you can see that this finite interval get matched to the whole real line. Okay, actually you guys see this idea before, just that you didn't write it out. So in this case, yeah, actually we can pick fx to be tangent of x minus half pi. Okay, hopefully I'm correct. So I need to change the period because I think this period is what 0 to power 2. If I'm not wrong, 0 to power 2. Okay, if you just look at okay, let me write down. So if you just look at y equals to tangent x, I think the period is 0 to power 2. So you need to change your period. Okay. Right. So let's continue. For the definition. So we said that a set S is denumerable. Okay, denumerable if it is as many as a natural number. And then we will say that a set is countable. This one match with your intuition of counting. I can count 1, 2, 3, 4, 5, 6, 7. You can count it if it is finite or innumerable. Okay, the infinity of natural number is still countable. Okay, meaning you still can put a label of 1, 2, 3, 4, 5, 6, 7, 8. Later, I will show you an infinity that you cannot label. Okay, that you cannot label. Okay, so the proposition is, so this is very life experience. If x is denumerable, if and only if its elements can be enumerated. Okay, so what it means by enumerated here, in a non-terminating sequence. Non-terminating sequence, A1, A2, blah, blah, blah. And then we'll say that A1, A2, blah, 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 is an enumeration of. Okay, so meaning you can arrange them, okay, one by one behind the other. Okay, actually, there's nothing to prove here. Okay. Next proposition. We'll say that any enumerable set is infinite. Okay. So you might ask the question, hey, I thought you said it's as many as natural number already, but did we deduce that natural is infinite yet? Actually, not yet. Okay, so this is equivalent to just shows that sufficient to show that n is not finite. Okay, since all the denumerable set is by injection with n. Okay, we just need to settle that n is not since any numerable set is equivalent to n. Okay, so I think this is a famous contradiction. One of the famous contradictions. How to show that n is finite. Lại中意来 try 先。n is not finite. Contradiction. So suppose what? By contradiction, suppose you want to prove n is not finite, so you want to use contradiction. Suppose n is finite. So what does it mean by n is finite? So this means n is equivalent to some set that containing 1, 2, 3, up to some small n. Any contradiction or not? 有 contradiction 啊？相信吗 ？n 里面只有1到 n 吧？还有什么 ？n 加1呢？为什么加1 ？But n plus 1 is also in n. Okay, so contradicting the equivalence. So meaning it's not surjective. So it's not surjective, this projection. Okay. Very straightforward. Okay, next. Maybe seems straightforward, but it's not that trivial. Let's go to that. Okay. Or you still want to copy? Okay, let's go to the next statement. Proposition. Any subset of a countable set is countable. Sounds very intuitive, can rhyme, can rap. Any subset of a countable set is countable. But why is it true? Countable means what? Either it is finite or denumerable. Two cases. Yeah, two cases. Okay, so two things could happen, either finite, either denumerable. Correct or not? Think about it. If you have a finite set, right? If you pick out a subset, obviously it's still finite. If it's denumerable, what kind of subset you can have? Either finite or denumerable. I think this is the cases you meet in the question 3 of assignment 1. Okay, so the subset of n could be finite. You can find the least element, or I give you an infinite one, you still can find the least element. Okay, and so there are two cases you need to consider. So how to prove here? Okay, let's prove it very quick. So let A be countable. So just now we said that if it is countable, right, we can count 1, 2, 3. In particular, we can put label. So what does it mean in maths? So we say that A has an enumeration. And we have an enumeration. So we can put label. So meaning in layman term, we can put labels on A1, A2, A3. Okay, which could terminate. Okay, it could terminate one. Okay, if A is finite. Just now, the case we consider is denumerable, so it won't terminate. But now we could include the case where it is finite. But if you take a subset of A, meaning what? Huh?
So now you make your A into sequence. If you take a subset of A, you are taking a subsequence. Okay, actually you are constructing a subsequence. Okay, so subsequence, let's call it A, I1, AI2, AI3, and so on. Okay, so what happens here? Either this subsequence end, which is finite, terminate at some point. Either this subsequence doesn't end, which is infinite, but still can be enumerated. Right? So it's counted. Okay. So either the subsequence terminate, in which case B is finite, or the subsequence, let's say it continues, which case B is enumerable. Enumerable. Okay. So both case, in both case, B is countable because we can enumerate them, we can label them. Okay. How many more? Okay, I think we should do, let's see, one more. Let's do one. Yeah, let's do one more. Then I think we can break here. So let's do one more. This one, I want you to think for a moment first before I tell you the answer. So the set rational number is the numerable. Okay, just now we show you that Z is the numerable. How about rational number? I think about it. Let me list some rational number for you. 1, 0, and then 2, 3, 4, 5, right? And then you got half, right? And then what do you have? 2/3, right? Okay, sorry. What am I doing there? 1/3. Where is 1/3? Eh? Yeah, and so on. Okay, I don't want to list. Okay, I list in the line. What are the rational numbers? So it goes 0, 1, 2, is in there. Right? And then you also got half here, 3/2 here. Then 1/3, 1/3, 2/3, still inside here. And yeah, something like that. Can you label them in sequence? Any idea? Any idea? You got -1, so got 2 sides. Idea? Want to try? discrete 画格子 ，OK， discrete 教你什么？跟我讲一下。忘记了，画格子。Someone can recall 呢？画什么格子？跟我讲一下。1, 2, 3, 4讲话。OK，1 在哪里？1, 2, 3,
4, and then drawing column, what do you mean? 旁边在画什么？它在旁边。What do you mean? 1、2、3、4这样。下面1、2、3、4。And then what you want? Vertical. 哦，这样2、3、4来的。And then oh, so you move, make a table. Okay. Oh, like that, like this. And then here, like 2/1, 2/2, 2/3, 2/4. Okay. Okay, and so on. Okay. Then down. Move down first. Up there. Down.
No, up to right.
To right. Does it matter? Okay, let's compute your path first. Go diagonal down. Okay. Or down 1. Okay, diagonal out. Okay, I think everyone got this pattern already. But let's say just now I don't want to go there. I'm very rebellious, so I want to go down first. You know. And then I still can go down, man. And then I go down, I do your diagonal also can. Do it later. Can or not? 对不对? Do I miss a point? Or I need to change my path? Yeah. So as long as you can give a consistent way to tell your path, that's fine. Cannot. Yeah. But this one is just a positive or negative one. How to? Sorry. So you want to compose with that? Okay. Yeah, you should. You're sure you can do that. Or let me show you. So if you use this method, right, this will give you that the positive part is equivalent to n. Okay. But since you already have A1, A2, A3 like that, right? What you can do is you can put all your 0. So let me write better. So this implies this, and then what you can do is you put a 0 here, A1 here, negative A1 here, A2 here, negative A2 here, and so on. Okay, and then to label all the rational. Okay. Okay. Yeah. So what's it true? Why this thing is true? Why this thing is true? Why? Why? Because this path only passed by 1 point once. And then you measure all the points you pass by. I don't know. You want to give label to all these rational number, right? 对吗？懂什么意思吗？
Skip those points that its principal formula has given right?
It's not confirmed. Would you?
I mean, you just give the points back to your.
Then I think your label is not good, eh? Your table method is not good. Oh. I got a better way. Huh? What's a better way here? Let me see. So I got a better way. It's like that. Okay. So I put 1 here, 2 1 here, 3 1 here, 4 1 here, 5 1 here, and then so on. Okay. And then second, we'll put 1/2, 3/2, 5/2, 7/2. Meaning I skip all the power of 2. Okay. And then I'll put 1/3, 2/3, 4/3, 5/3. So I skip all the power of 3 if I consider the denominator as 3. And so on. Okay. Okay. And then I can do a maze method here.
What's the maze method? So I can go down, go right, go up, go right, go down, go left, go down, go right, go right. Like this. Okay. No? Yeah. Okay. Okay, so when I consider the numerator, I already get rid of the, like what you said, the thing that have the same common factor. I remove it. Then again, I do this. Okay, now. There's one student now suggesting this. Does everyone see this or not? This one? Can you imagine? Can you also can do this? So you see, this is your path. Right? Well, I think actually depends on how you arrange your rationale first, and then you think of a path. Okay. Yeah. Any question? Any question? Okay. Yeah, if no question, then we will extend our assignment to next Tuesday, and then the next assignment will decide again. See you next week.